Hello everyone. Uh, Welcome to Double E Academy. Myself Vinay BK. So this is a second video of electric circuit analysis. Uh, Today we're going to discuss about mesh analysis with a simple example by solving a numerical. You can see the screen now. So in this mesh analysis, we are considering a circuit which is having two voltage sources, that is independent voltage sources, and we'll be having the resistors. We need to find current flows to 6 ohm resistor. That is nothing but current flows to here. We need to find this current. Whatever the current that flows to 6 ohm, that we need to find. So it as I, we need to find the value of I. So to find this current, we need to apply mesh analysis method. So before going to start with a problem, we should know something about mesh analysis. Mesh analysis you should know. Then only can able to use mesh analysis, you can apply and you can understand everything. Okay. So now, so it has a certain rules to apply mesh analysis. For example, I'll take a rules you can consider. So the rule is to apply KVL for the mesh. You can also call this as mesh current analysis or else loop current analysis. With the help of this mesh analysis, we can able to find all the branch currents. We can able to find all the branch currents. So steps is that we can observe the problem. They are given circuit diagram like this simply. So we need to simplify the circuit, or we need to rearrange the circuit diagram as per the requirement to get the value of current flow through 6 ohm resistor. Okay. So for that first point, we need to understand to solve the mesh analysis problems, we need to follow these steps. So step number one, you can consider if they are given the direction of current along with the loop, that is fine. If they are not given, give direction of current, give direction of current along with the loop, current along with the loop is very important. If they are given the loop direction along with the current, that is fine. If they are not given, means we need to give a loop direction along with the current. And second point we are considered for a second point, once after giving the direction of current along with the loop, then give polarities, sorry, polarities. Suppose if there is a resistor, in case of resistor, current flows from positive to negative, positive to negative. Suppose if there is a voltage source, if there is a voltage source, then current is flowing from negative to positive. That is what you all the rules you know. So just use if there is a voltage source. Suppose if there is a voltage source, the current always flows from negative to positive. Negative to positive. This is all. So first give the direction of current along with the loop, and the second one is mark or else give polarities for resistor or else voltages. You can call it as, you can give the direction or you can give the polarities for the passive elements as well as active elements. Once after giving that, mark the first or second, anyone you can consider first or second polarities, sorry, polarities, then write equations accordingly, equations accordingly to get the unknown value of branch currents. So once after writing the equations, solve the equation. Solve the equations with the help of calculator or can use the Kramer's rule also to solve the equations. So anyhow, it is only having registers you can directly solve with the help of calculator because you're getting only a real value. Suppose if there is a AC circuit, we need to solve with the help of Kramer's rule. So that problem I'll explain in next video. That will be very interesting to know about the Kramer's rule, to apply, to solve the equation without help of calculators and all. Okay. So these are the steps now. Once after solving the equations, you'll get the current, then can see based on that you can find the values of current. So now you can see the first step, direction of current along with the loop. Direction of current along with the loop. So I'll consider the circuit. So for this circuit, first what you did give the direction of loop along with the current. So that I'll consider now I'll give the direction of loop along with the current either clockwise or anti-clockwise. Remember, if they're not given, can consider any one direction either clockwise or anti-clockwise. You can give I1 is flowing here. If you're getting confusions to write these type means first give a namings to the particular branch. I can give here now A, B, C, D, E, F, G, H. Okay. So once after giving that, so now what I will do? So now I'll give a loop direction. So just for your reference, I'll erase once again. Then we can use the loop direction. I can select here. Okay, loops. So you can see now, for example, I1 is flowing here. I'll write it. I1 is flowing here, and I2 is flowing here. In this loop, I2 is flowing, and in a third loop, I3 is flowing. And remember one more thing. So if you are having three loops, it means that it is having you should get three equations. Either it will be having two unknown currents or one unknown current, or else all the three unknown currents we need to find. Okay. So now we don't know the values of all the three currents, so that we need to find all three unknown currents. With the help of that, we can find current flows through 6 ohm resistor. So now I'm giving the loop direction. So clockwise or else anti-clockwise can use. So I'm giving the clockwise direction. So now based on the direction and loop of the current, you can observe the first loop is, I will write it here, A, B, G, H, A is your first loop, loop 1. So now, so I gave the direction of current. Similarly, you can give polarity. You can mark the polarity based on this now register. Current is flowing from A to B. So plus to minus. Similarly B to G plus to minus. Similarly here H to A. There is a voltage source. We already have minus and plus here. So like that you have to give polarities for all the loops. So you can consider second loop that is B, C, F, G, B because it is a clockwise direction. If it is anti-clockwise, can read it in a anti-clockwise way. So now in a B, C, F, G, H, B to C, I2 is flowing so that plus and minus I'll mark it here. Similarly here, so the 6 ohm plus and minus. Here also it is plus and minus. Similarly for the third loop also you can observe C to D plus minus. Okay, there is a voltage source again plus minus they are only given here plus and minus. So these steps we need to remember. First step, give direction of current along with a loop. I was given as I1, I2, I3. You can also give this as IA, IB, IC. So once after giving the direction of current along with the loop, then I will mark the polarities. Then I will apply KVL. Then I will apply KVL or else mesh analysis method. So now I will consider uh, move it now. So now I'll consider loop 1. That is nothing but you can see the loop 1 is nothing but A B G H A. A B G H A. So apply KVL. Apply KVL to this loop. So now based on this direction, as I told, based on this direction, so I'll mark the second polarity. That is plus here, similarly minus here. The direction is clockwise so that here also minus. So once after marking the polarity, I will write the expression as per the KVL statement. The algebraic sum of, that is in any closed loop, algebraic sum of all the EMF and drops are equal to zero. Either it is a resistive drop or impedance drop if you are considering AC circuit. So now for loop 1, you can observe the equation. I start from the voltage source. You can start it from anywhere. Okay. So I will write it here plus 10. I already marked the polarity. Minus 2. Which current is flowing here? I1 is flowing. So here I1 is flowing. So that minus 2 into I1. Similarly come here B to Z. So B to Z, you can observe B to Z. I will write it for your reference somewhere here. B to Z. So there is a B and G. In between that, you can observe A to B also there. Like this, there is a voltage source. So I am not writing that value. I'll to concentrate this. So again, B to C, there is a resistor. One more loop that is having a 6 ohm resistor like this. B to Z. So which current is flowing from A, B, G, H? I1. See, I1 is flowing here with respect to 4 ohm. Similarly, B, C, F, G, B. I2 is flowing. So in this case, if you wanted to consider a branch B to C with respect to loop 1, if you consider branch B to G with respect to loop 1, you can observe, once again, you can observe this branch that is B to G, it is having 4 ohm resistor, but current direction you see. So in the loop 1, I1 is flowing, that is I1 is flowing from B to G, but in a loop 2, I2 is flowing from G to B. So that you can write current flows through 4 ohm. You can write current flows through 4 ohm. That is I4 ohm. We can write as I1 minus I2. I1 is flowing in this direction. This is a reference so that I'm considering I1 minus I2 for loop 1. Similarly, if you are considering loop 2, it is vice versa because loop 2 is a reference now so that I2 minus I1 for loop 2. So now I'll write once again. Observe the equation now once again. So for this, I will write already mark the polarities. So for your reference, I'll write the currents now. So at this branch, okay, I1 minus I2 is flowing. Similarly, at this branch, if the direction is upward, I2 minus I1 is flowing from B to C. I hope you are understanding this. So let us later I will mark. Okay. So now we'll write the expression plus 10 minus 2 into I1. So B to G. So I1 is flowing down. At the same time, I2 is flowing up here. So that I will write minus 4 into I1 minus I2 equals to 0. So now I'll simplify this. We'll get equation 1. So I'll write as it is 10 minus 2I1 minus 4I1. You can also write directly minus into minus plus 4I2 equals to 0. So I'll send all this expression on right side. It becomes 2I1 plus 4. Sorry, minus 2 minus 4 is nothing but 6I1. That is nothing but, once again, I will write equation 1 minus 2 minus 4 is nothing but minus 6. If we are sending that to right side, it becomes plus 6I1 minus 4I2 equals to 10. This is equation number 1. I hope you are understanding. So now I'll erase loop 1 to make it understand for loop 2 now. Okay. So now we can consider loop 2. So for the loop 2, how will write now expression? See B C G F, sorry, B C F G H. I will rewrite again here. Let us before that. Okay, can consider the loop 2 now. Loop 2 is nothing but loop 2 is nothing but B C F G B. Apply KVL again. So already giving the what you already having the loop direction I1, I2, I3. So just based on the direction you already gave the polarity. So now mark the polarity and write the expression. You know here upward direction, second polarity I am considering. Either you can consider first. But the rule is that for first loop, if you are considering the first polarity, for all the loop you have to consider first polarity only. For the first loop, if you are considering second polarity, you have to consider for all the loop you have to consider second polarity. So that minus I am considering that is second polarity I am considering for first loop. So that for all the branches I consider second polarity only once after giving the polarities. Okay. So now we'll write here. See now minus 4 into, you can observe the current now. I2 is flowing upward, I1 is flowing downward. The reference is second loop, so that I'll write minus 4 into I2 minus I1. Similarly, it will come here, second polarity minus 1 into I2 is nothing but I2 I'll write, or else minus 1 I2. Similarly, C to F, the I2 is flowing downward here now, but I3 is flowing upward, so that you can write minus 6 into reference is I2, so that I2 minus I3 that is equals to 0. So once after writing this now it is very easy. You just simplify, you'll get expression again. So I will simplify here minus 4I2 plus 4I1 minus I2 minus 6I2 minus into minus plus 6I3 equals to 0. Then I'll get one more expression that is nothing but I1 is only one term 4I1. So minus 4 minus 1 minus 5 minus 6 minus 11 I2 minus 11 I2. So I3 term only one, that is plus 6 I3 equals to 0. This is equation number. I hope you understand it. Similarly, we have to apply it for loop 3. Just apply KVL to loop 3, mark the polarities, write the expressions without wasting time. At loop 3 is nothing but CD. I will write here CDEFC. It is a clockwise direction, so that I am considering clockwise words. See now I will mark the polarity here minus, minus, minus. So here at the sixth one we can consider I3 is flowing upward direction, but I2 is flowing downward direction, and my reference is loop 3, so that I'll write I3 minus I2 into 6. The polarity is minus, so that I'll write here minus 6 into I3 minus I2. Currents are flowing opposite direction and the reference is third loop. Similarly here minus 4 into only I3 is flowing, so that minus 4 into I3, and there is a voltage source that is independent, minus 20 equals to 0. I'll send 20 on right side, then I'll simplify here minus 6I3 minus 6I3 plus 6I2 minus 4I3. I'll send 20 right side, it becomes plus 20 now. So now I'll get the expression, that is the third equation I'll get now. So you can observe the third equation. In terms of I1, I2, I3, that is 6 I2 minus 6 minus 4 minus 10 I3 equals to 20. This is equation number 3. So now solve equation 1, 2, 3 with the help of calculator. You can solve the equation 1, 2, 3 with the help of calculator. Then we get the values of I1, I2, I3. That is nothing but your unknown currents. You can call that as branch currents. So solve equation 1, 2, 3. 1 and 2, 3. So now once after solving this, so even I don't know the answer, I will solve it now. Let me check what are the answers we are getting. Go to the calculator, press equation 5, then write 3 unknowns, press 3. For first equation, we'll be having 6I1, that is nothing but we'll be having first 3 unknowns, 6 equal minus 4 equal I3 is 0 in equation 1, so that I'll write 0 and D is 10. Similarly for equation 2, 4 minus 11, 6, 0. Similarly for third equation, 0, 6 minus 10, 0, 6 minus 10, then B is 20. Press equal, we'll get the value of I1 as it will show in terms of X, Y, Z. You have to write in terms of I1, I2, I3. I1 0.9154 amperes. Similarly, I2 you are getting the I2 is plus equal, you get again minus 1.126 amperes, and I3 is you get again in terms of minus 2.676 amperes. But what they asked you to find? They asked you to find the value that is current flows through 6 ohm resistor. You need to find current flows through this 6 ohm resistor. So which current is flowing in 6 ohm resistor? That is nothing but I2 minus I3 or else I3 minus I2. Whatever you can consider. If it is I2 minus I3, you get plus. If it is I2 minus I3 minus I2, you get minus. So that now current flows through 6 ohm. That is I2 minus I3 is nothing but current flows through 6 ohm. I'll write here current flows through 6 ohm resistor is given by I2 minus I3. So that is nothing but I2 is minus 1.126, I3 is minus of minus 2.676. Get the answer? Just 1 second. Minus 1.126 minus into minus plus 2.676. You get 1.55 amperes. 1.55 amperes, and this is the answer. Suppose if I consider I3 minus I2, that is minus 2.676 plus 1.126, you get minus 1.55. So either I can use I2 minus I3 or else I1 minus I2. So now I3 minus I2. So now I used I2 minus I3, so I am getting positive. So that positive is nothing but the current is flowing in same direction. If it is a negative, current is flowing in a opposite direction. So this is how we have to solve the mesh analysis method with a simple example. So if you want a glance, so I will tell you once again within a second. So first we need to give the direction of loop. So I'll just erase once again to make you to understand. Just the steps you need to solve again. First mark the letters or numbers, whatever you want. Then once after that, give direction of current along with the loop if they are not given. So I'm giving the direction of current along with the loop, that is I1, I2, I3, either clockwise or anti-clockwise, anyone you can give. The current will get same answer, either it is a positive or negative. If you're getting negative, current is flowing in a opposite direction. So once after giving the loop direction along with the current, give polarities minus plus for voltage source. Here A to B, current is flowing through a resistor from higher potential to lower potential, plus to minus, plus to minus. Similarly for loop 2, so here plus minus, here also plus minus, plus minus. Similarly, plus minus, plus minus, plus minus. Then, based on the loop direction, mark the second polarities, write the expressions. At B to Z, with respect to loop 1, I1 minus I2 is flowing. With respect to loop 2, I2 minus I1 is flowing. And from C to F, with respect to second loop, I2 minus I3 is flowing. With respect to third loop, I3 minus I2 is flowing. Then we'll get some expressions. So once after getting the expressions, you just solve with the help of calculator. We get these answers. Either also you can find current flows through 4 ohm. Suppose if they ask you to find current flows through 4 ohm, so I1 minus I2 is flowing through 4 ohm. For example, if they ask you to find current flows through 4 ohm resistor, this I1, I2, this current. If they ask you to find that I4 ohm, I1 minus I2 is flowing. So we already know the value of I1, we already know the I2 value. Then you just get the difference between I1 and I2 will get the current flow through 4 ohm in terms of amps. You just try this one. I hope you are understanding the problem, and thank you so much for watching the video. If you like the video, please do like and subscribe. Share as much as possible to the electrical and electronics students, that is ENC and the EE students. Thank you one and all. Have a nice day.